Good afternoon, students. This is Lohita. Today we are into another zoology NEET class where we are going to learn few concepts related to human excretory system. These excretory products and elimination chapter. We are going to learn few concepts related to it. Okay. So today we are going to learn the regulation of kidney function. We are going to learn regulation of kidney function. So the main job of the kidney is to perform osmoregulation. Osmoregulation is the main job of the kidney. So osmoregulation is nothing but osmoregulation is nothing but the maintenance of the water and solute concentrations in balance is called as osmoregulation. Osmoregulation is nothing but the maintenance of the water and solute concentration balance in the body is called as osmoregulation. So here is osmoregulation, water and solutes are maintained in balance in the body. That is called as osmoregulation. And kidneys are the main organs which are going to help in osmoregulation. Okay. Kidneys are the main organs which help in osmoregulation. And the kidneys are going to maintain osmoregulation by utilizing some hormones. There is some kind of hormones which are going to help in maintaining osmoregulation in the body. So let us learn what are those hormones and how they are going to affect the kidneys function. So let us learn in today's class. Okay. So there are different hormones like ADH. And we have angiotensin 2 and atrial natriuretic hormone, and we have aldosterone. These are the different hormones which are going to affect the kidneys functioning. ADH, angiotensin 2, atrial natriuretic hormone, otherwise called atrial natriuretic peptide or atrial natriuretic factor, and aldosterone. These are the hormones which are going to affect the kidneys functioning. Let us learn in detail how each of them is going to affect the kidneys functioning. So first we learn regarding ADH. ADH is called as anti-diuretic hormone. ADH is anti-diuretic hormone. The other name for this hormone is vasopressin. The other name for this hormone is vasopressin. So this in our body, in the brain region, we have a region which is called as hypothalamus. In our brain, there is a region which is called as hypothalamus. So hypothalamus is actually a part of our brain. So in the hypothalamus of the brain, there are osmoreceptors. There are osmoreceptors in the hypothalamus region of the brain. So these osmoreceptors in the hypothalamus, they are highly sensitive to solute concentrations in the body. They are highly sensitive to osmoreceptors. They are highly sensitive to solute concentrations in our body. They are sensitive to solute concentrations in our body. So whenever there is an increased loss of fluid from the body, immediately these osmoreceptors, they are going to get switched on and they are going to stimulate the hypothalamus to release the anti-diuretic hormone via neurohypophysis. I hope you got me. See, the osmoreceptors, whenever there is increase in the solute concentration, whenever there is increase in the body fluid loss in our body, whenever there is increase in the loss of body fluids from the body of the individual, then the osmoreceptors are going to get switched on and they are going to stimulate the hypothalamus to release anti-diuretic hormone via neurohypophysis. When the anti-diuretic hormone is produced by the hypothalamus via neurohypophysis, this anti-diuretic hormone, name itself is indicating that it is going to prevent diuresis. What is this anti-diuretic hormone going to do? It is going to prevent diuresis. Diuresis is nothing but increase in the loss of water from the body is called as diuresis. Diuresis is nothing but increased loss of water from the body. So, antidiuretic hormone is going to prevent the diuresis. That means it is going to cause increase in the reabsorption of water from the distal convoluted tubule and the collecting ducts, which is going to cause increased reabsorption of water from the distal convoluted tubule and the collecting ducts. Okay, so this is the job which is done by antidiuretic hormone. Antidiuretic hormone, whenever there is increased loss of fluids from the body, it is going to prevent diuresis by increasing the reabsorption of water from the distal convoluted tubule and the collecting duct. So when there is a large amount of body fluid volume, then what is going to happen? When the body fluid volume is increasing, fluid volume in the body, if it is going to increase, then the osmoreceptors, they are going to be switched off. They are switched off. When there is increase in the body fluid volume, then what is going to happen? Osmoreceptors, they are going to get switched off. When the osmoreceptors are switched off, then there is no production of antidiuretic hormone from the hypothalamus. The hypothalamus is now not going to produce any antidiuretic hormone. When they are osmoreceptors are switched off, antidiuretic hormone is not going to be produced. When the antidiuretic hormone is not produced, there is no reabsorption of water from the distal convoluted tubules and collecting ducts, and it is going to cause the formation of a dilute urine. Dilute urine is going to form. That means increase in the loss of water. Loss of water from the body is going to occur through urine. Okay, that is how the antidiuretic hormone is going to help in maintaining the body fluid volume. When the body fluid volume is decreasing, that means when there is an increased loss of fluids from the body, then the osmoreceptors present in the hypothalamus are going to be switched on, and they are going to stimulate the hypothalamus to release antidiuretic hormone via the neurohypophysis. And when that antidiuretic hormone is produced, it is going to prevent diuresis by causing increase in the reabsorption of water from the distal convoluted tubule and the collecting duct. And if the case is becoming opposite, when the body fluid volume is increasing, then what is going to happen? The osmoreceptors are going to be switched off. When the osmoreceptors are switched off, then there is no production of antidiuretic hormone. When there is no production of antidiuretic hormone, then there is no reabsorption of water from the distal convoluted tubule and collecting ducts, as a result of which dilute urine is produced and resulting in the increased loss of water. In that way, again, the body fluid volume is maintained. Okay, this is how the antidiuretic hormone is going to help in maintenance of the body fluid volume. So, in certain conditions, due to the lack of proper amounts of antidiuretic hormones, or if the receptors for antidiuretic hormone are not working properly, if there is no production of antidiuretic hormone, or if the receptors for antidiuretic hormone is not working properly, then it is going to lead into a disease which is called as diabetes insipidus. Diabetes insipidus. This is a disorder which is caused due to the lack of antidiuretic hormone, or due to the lack of receptors for antidiuretic hormone. There might be any lack of antidiuretic hormone, we can say it as defect. We can even clearly say that defect. Lack of antidiuretic hormone or the defect in the receptors of ADH is going to result in disorder called diabetes insipidus. During this condition, when ADH is not produced or if the receptors for ADH are not available, then what is going to happen? Diuresis is going to happen. In that person, there is increased loss of fluids from the body through the urine. Okay, so that this loss of fluids from the body is going to go up to 20 to 25 liters of urine in a day. During diabetic insipidus, the person is going to excrete around 20 to 25 liters of urine in a day. But a normal healthy individual is going to eliminate only 1 to 1.5 liters of urine in a day. Isn't it? But in this individual suffering from diabetic insipidus is going to the body. The person is going to suffer from dehydration. The person is going to suffer from dehydration. And also fall in the blood pressure. The person is going to suffer from dehydration and also fall in the blood pressure. Okay, this is all that we have to learn in each point of view. These are all the concepts that we have to learn related to antidiuretic hormones. Okay, and one last point in this topic is, see, we are very familiar that the person who are having alcohol or consuming foods containing caffeine like tea or coffee, they are all going to cause increased loss of fluids from the body. They are going to act like the diuretics, that is alcohol as well as the substances containing caffeine. They are going to cause diuresis. They are going to cause diuresis. Both of them, alcohol and all those substances containing caffeine, they are going to cause diuresis because they are going to interfere with the ADH production or the action of ADH. Alcohol is going to interfere with the ADH production, whereas caffeine is going to interfere with the ADH action. Okay, that is why these two products, they are going to cause diuresis in the body. That is why those people who are consuming alcohol or caffeine, they also eliminate large amounts of fluids from the body through urine. Okay, this is all concepts we have related to ADH. Then let's move on to the next hormone, angiotensin 2. So we are going to learn regarding angiotensin 2. How is this angiotensin 2 going to regulate osmoregulation, that we are going to learn now. So whenever there is any decrease in the blood pressure, whenever there is any decrease in the blood pressure, or whenever there is any decrease in the blood volume or the body fluid volume, okay, whenever there is any decrease in the blood pressure or the blood volume, then what is going to happen? The juxtaglomerular apparatus, we have learned regarding this already. It is present in the nephron. So this is present in the nephron. The juxtaglomerular apparatus is going to produce an enzyme which is called as renin. The juxtaglomerular apparatus is going to produce an enzyme which is called as renin. This is otherwise called as angiotensinogenic. Okay, the juxtaglomerular apparatus of the nephrons is going to produce the enzyme called renin or angiotensinogenase when the blood pressure is going to fall or the blood volume is falling down. At that time, from the juxtaglomerular apparatus, the enzyme called renin, which is otherwise called as angiotensinogenase. Please note the spelling of renin clearly. It is R-E-N-I-N. We have another enzyme called as renin, which is going to have a spelling R-E-N-N-I-N. But this R-E-N-I-N is associated with our controlling the kidney's function. The R-E-N-N-I-N is an enzyme which is related to our digestive system. Okay, so this enzyme renin is going to convert angiotensinogen is converted into angiotensin 1. Angiotensinogen is converted into angiotensin 1 in the presence of the enzyme renin. In the presence of the enzyme renin, angiotensinogen is converted into angiotensin 1. And again this angiotensin 1 is further converted into angiotensin 2. Angiotensin 1 is converted into angiotensin 2 by angiotensin converting enzyme. Angiotensin converting enzyme. angiotensin converting enzyme. Angiotensin converting enzyme is going to convert angiotensin 1 into angiotensin 2. And this conversion of angiotensin 1 into angiotensin 2 is going to occur mainly in the lungs. It's going to occur mainly in the lungs capillaries because the angiotensin converting enzyme is present mostly in the capillaries of the lungs. That is why this conversion of angiotensin 1 into angiotensin 2 is going to occur mainly in the lung capillaries. Now this angiotensin 2 is going to stimulate, the adrenal cortex to release the hormone which is called as aldosterone. For the release of the hormone aldosterone from the adrenal cortex. Let us see what this aldosterone is going to do. Till now we have studied that only when it can decrease the blood pressure or the blood volume, the juxtaglottic apparatus is producing renin, otherwise called as angiotensinogenase, which is converting angiotensinogen into angiotensin 1. Angiotensin 1 is converted into angiotensin 2 by angiotensin converting enzyme in the lungs. This angiotensin 2 is going to stimulate the adrenal cortex to release aldosterone. So let us see what this aldosterone is going to do. So this enzyme, hormone aldosterone is a hormone. Aldosterone is going to cause increase the reabsorption of water. It is going to cause increase the reabsorption of sodium. It is going to cause increase the reabsorption of sodium. Whenever there is an increased reabsorption of sodium, it is going to directly and indirectly cause increase in the reabsorption of water. It is going to cause even increase in the reabsorption of water. Whenever there is increase in the reabsorption of sodium, then definitely there will be reabsorption of water also. Okay, so the aldosterone is going to cause increase the reabsorption of sodium from the renal tubules, as a result of which there is even an increase in the reabsorption of water, and this aldosterone is also going to cause secretion of potassium into the renal tubules. It is also going to cause secretion of potassium into the renal tubules. It is going to cause secretion of potassium into the renal tubules. So all these three responses, reabsorption of sodium, reabsorption of water, secretion of potassium into the renal tubules, all these three events, they are going to cause increase in the blood pressure and blood volume. All these three events, they are going to cause increase in the blood pressure and increase in the blood volume. So in that way, the normal volume of the blood and the normal pressure of the blood is again achieved because of the renin, angiotensin and aldosterone. So all these network of systems which are working together, all these enzymes and hormones which are working together are together called as RAS. They are all together called as RAS, which means renin, angiotensin, aldosterone system. Renin, angiotensin, aldosterone system. So all these things, the renin, angiotensin and aldosterone, all the three of them work together in order to maintain the body fluid volume. So that is why all the systems, all these enzymes which are working together are together called as RAS, renin, angiotensin, aldosterone system. Okay, so this is all that we are regarding angiotensin and aldosterone. Okay. Then let us discuss regarding the other last hormone which we are having in regulation of kidney functioning. So we have atrial natriuretic peptide, which is otherwise called as atrial natriuretic hormone or atrial natriuretic factor, atrial natriuretic peptide or atrial natriuretic hormone or atrial natriuretic factor. All of them are same. So we can write it in short form as A and P or A and F when we are calling it as atrial natriuretic factor. So this atrial natriuretic peptide or atrial natriuretic factor is produced by the atria of the heart. It is actually produced by the atria of the heart. When is it produced? Whenever there is an increased flow of blood in the atria. Whenever there is an increased flow of blood into the atria. That means whenever there is an increased flow of blood to atria. Okay, the increased flow of blood to the atria is going to cause increase in the blood pressure and increase in the blood volume. So these are all going to happen when there is an increase of the flow of blood into the atria. So all these conditions are going to occur simultaneously. That is, there is going to be an increase in the blood pressure and increase in the blood volume. So whenever there is increase of flow of blood to the atria or increase in the blood pressure or increase in the blood volume, then from the atria, atrial natriuretic peptide is going to be produced. Okay, atrial natriuretic peptide is going to be produced. This atrial natriuretic peptide is going to cause dilation of the blood vessels. Dilation of the blood vessels. Okay, whenever the blood is going to cause the dilation of blood vessels, and it is going to even decrease the reabsorption. It is going to cause the decrease the reabsorption of sodium from the renal tubules. Whenever there is any decrease in the reabsorption of sodium from the renal tubules, obviously there is going to be decrease in the reabsorption of water also. Reabsorption of water also. Okay, so all these other situations which are going to occur when atrial natriuretic factor is produced from the atria. So atrial natriuretic factor is going to cause dilation of the blood vessels, reabsorption, decrease the reabsorption of sodium, which is ultimately going to cause decrease in the reabsorption of water. As a result of all these things, what is going to happen is the blood volume is going to decrease and come back to normal, and also the blood pressure is going to decrease. The blood pressure is also going to decrease. So here we have observed that the RAS system was working to increase the blood volume and blood pressure, whereas this atrial natriuretic factor is going to cause decrease in the blood volume and decrease the blood pressure. It means that the atrial natriuretic factor and the RAS, both of them, they are going to work antagonistic to each other. That means both of them, RAS and the atrial natriuretic factor, both of them, they are going to work opposite to each other. Both of them, they are going to work opposite to each other. In that way, both of them, they regulate each other's function. Whenever there is any increase in the blood volume, then this atrial natriuretic factor is produced. Whenever there is any decrease in the blood volume, RAS system is going to be activated. In that way, both of them will work together opposite to each other in order to maintain the blood volume, in order to maintain the osmoregulation in the body. So this is all that we have regarding the kidneys function regulation. Let us learn the next concept, that is micturition. The next concept we are having is micturition. See, the urine is formed in the kidneys, isn't it? The urine is formed in the kidneys through the ureters. The urine is passed down in the respiratory tract. From the kidneys, the urine is produced, isn't it? From the kidneys, the urine is carried by the ureters through peristalsis. To the peristalsis of the ureters. The urine is going to move into the urinary bladder. Okay, the kidneys urine is produced. From the urine, it is going to be passed by the ureters to the urinary bladder by the peristalsis of the ureters. Urine is going to be flowing into the urinary bladder. Urine is going to flow into the urinary bladder by the peristalsis of the ureters. Okay, so the urinary bladder, we have already learned is that the urinary bladder is the storage organ for urine. The urinary bladder is the storage organ for urine. Urinary bladder is going to store urine. So the urinary bladder's normal capacity is 350 ml to 400 ml. This is the normal capacity of storage of urine. The urinary bladder, it can easily store 350 ml to 400 ml of urine. Okay. But the urinary bladder, it is stretch resistant. It is stretchable. The urinary bladder's wall, it is stretchable. So, though this is the normal capacity of the urinary bladder, it can hold up to 700 to 800 ml of urine. It can hold up to 700 to 800 ml of urine. But right after 500 ml of urine only, right after storing 500 ml of urine only, the pain is going to start. The pain of storing urine, the pain of the urinary bladder being full is going to start after 500 ml only. After the urinary bladder is filled with about 500 ml of urine, from then only the pain of storing urine in the urinary bladder is going to start. But it can be filled up to 700 to 800 ml of urine. Okay. So, whenever the urinary bladder is going to be filled with urine, whenever the urinary bladder is going to be filled with urine, at that time there is actually filling reflex is going to occur. That means filling reflex is nothing but this is the reflex, this is the nervous control of the urinary bladder to not contract. This is the reflex, which is the control of the urinary bladder to get filled. So during filling reflex, filling of urinary bladder is going to occur. Filling of urinary bladder is going to occur. And again, after filling reflex is done, after the urinary bladder is full, then voiding reflex is going to occur. Voiding reflex. Voiding reflex is nothing but the reflex which is going to cause the emptying of the urinary bladder. Voiding reflex is that reflex which is going to cause emptying of the urinary bladder. Voiding reflex is that reflex which is going to cause emptying of the urinary bladder. Okay. So all those reflex reactions, all those reflex events which are involved in the passage of urine outside is called as micturition reflex. Micturition reflex is nothing but all those nervous responses which are involved in the passage of urine outside is called micturition reflex. The passing of urine outside the body, the passing of urine outside the body is called as micturition. Micturition is nothing but passing of urine outside the body. Passing of urine outside the body is called as micturition, and it is controlled by the micturition reflex. It is controlled by the micturition reflex. Whenever the urinary bladder is full with urine, immediately, because of the stretching of the urinary bladder, the sensory signals are sent to our central nervous system. Okay, whenever the urinary bladder is full, because of the stretching of the urinary bladder, the sensory signals will be sent to our central nervous system. In turn, the central nervous system is going to give motor signals to the urinary bladder. It is going to give motor signals to the urinary bladder, and the motor signals received by the urinary bladder is going to cause the contractions of the urinary bladder. The motor signals received by the urinary bladder is going to cause the contractions of the urinary bladder, because of which the urine is going to be pushed out of the excretory system through the urethra. Through the urethra, the urine is going to be passed out, and passing out of the urine is going to be a voluntary response. It is a voluntary action. Okay, so that voluntary control of micturition is under the control of a nerve which is called as pudendal nerve. Pudendal nerve. So this is the nerve which is going to control the voluntary micturition. This is the nerve which is going to control voluntary micturition. That is why this nerve is also called as nerve of micturition. The pudendal nerve is also called nerve of micturition. Nerve of micturition. Okay. So let me just repeat the entire concept once again, then we'll continue with the next concept. So we are having the micturition, that is when the kidneys are going to form the urine, it is passed from the kidneys into the ureter. From the ureter, the urine is going to be passed on to the urinary bladder by the peristalsis of the ureter. Okay, by the peristalsis of the ureter, urine is going to be passed on to the urinary bladder, and this urinary bladder is going to be filled with urine. And the urinary bladder is normally going to have a capacity of 350 to 400 ml, but it can withhold, because of its stretchability, it can withhold even a large amount of urine, up to 700 to 800 ml of urine also it can store. But right after 500 ml of urine in the urinary bladder, only severe pain is going to start. Okay, severe pain is going to start. So the filling of the urinary bladder is under the control of the filling reflex, and voiding reflex is the one which is going to stimulate the urinary bladder emptying. Okay. Then we have the micturition reflex, which is going to control the micturition. Micturition is nothing but the passage of urine out of the urinary bladder through the urethra is called as micturition. The passing of urine out of the urinary bladder through the urethra is called micturition. And this micturition is under our voluntary control. It is controlled by pudendal nerve, which is going to voluntarily control our micturition. That is why this pudendal nerve is called nerve of micturition. Okay, let us learn more concepts related to urine now. We will learn related to urine now. So urine is actually slightly acidic. That means it's going to have a pH of 6. This is the pH of urine. 6 is the pH of urine. Okay, and it is light yellowish in color. It is light yellowish in color. And it is going to have a characteristic odor. Isn't it? Urine is generally going to have its smell. By smelling only we can identify that it is urine, isn't it? So that is, urine is going to have a characteristic odor. So it is slightly acidic, having pH 6, light yellowish in color, and having a characteristic odor. And normally a healthy individual is going to eliminate 1 to 1.5 liters of urine in a day. The normal individual, healthy individual, is going to eliminate 1 to 1.5 liters of urine in a day. Okay, so the urine, out of the urine, 96% of the urine is going to be water. The remaining 2% is going to be urea. And this 2% of urea in the urine is going to be around 25 to 30 grams. 25 to 30 grams of urea is excreted every day by normal individual. This 2% of urea of the urine is going to account for a total of 25 to 30 grams of urea in a day. Okay, and the remaining 2% is going to be other solutes. Okay, by just observing the composition of the urine, many disorders related to kidneys and many other disorders related to the body can be identified. Many disorders related to the kidneys and many other disorders related to the body of the individual can be identified. For example, let us take an example and see. Okay, for example, if there is glucose in the urine, which is the condition of presence of glucose in urine is called glucosuria. That means the presence of glucose in the urine. Then sometimes there are also ketone bodies in the urine, which the condition is called ketonuria. Okay, glucosuria means presence of glucose in the urine. Ketonuria means the presence of ketone bodies in the urine. So the glucosuria and ketonuria, these are the conditions which are generally found in diabetes mellitus. Okay, so this is how How? By estimating the composition of urine, we can identify the presence of any disease in the individual, and also different disorders related to the kidneys can be identified by just observing the composition of urine. Okay, so then let us learn. This is all how we have learned regarding the kidneys, how they are participating in excretion. We have learned till now, and there are even other organs in our body which are going to help in excretion. Let us see what are those organs and how they are going to help us in excretion. Let us learn now. So we have the other organs involved in excretion. We are learning other organs involved in excretion. We are going to learn now. So the first organ involved in excretion we are going to learn about is lungs. Lungs, they are going to eliminate carbon dioxide from our body. They are going to eliminate carbon dioxide from our body. They eliminate about 18 liters of carbon dioxide. 18 liters of carbon dioxide in a day. Lungs are eliminating carbon dioxide from the body. They eliminate about 18 liters of carbon dioxide in a day. And even water is also eliminated from the lungs. Water is also eliminated from the lungs. And that water which is eliminated from the lungs is going to be in the form of water vapor. Okay? So water is eliminated from the lungs in the form of water vapor. Okay? And some other volatile substances. Volatile substances in the sense what? Volatile substances are those substances which can be converted into a gaseous state. Those substances which can be converted into gaseous state, either a solid or a liquid, which can be converted into the gaseous state directly, is called as volatile substances. Isn't it? Either a liquid or a solid which can be converted directly into a gas is called volatile substances. So lungs are going to eliminate carbon dioxide, water vapor, and volatile substances from our body. Okay. Then the next organ we are going to learn about is liver. Even liver is going to eliminate some waste materials from our body. Like liver is going to degrade the red blood cells hemoglobin. It is going to degrade the hemoglobin from the red blood cells. It is going to degrade hemoglobin of the red blood cells and convert hemoglobin into bile pigment. It is going to convert hemoglobin into bile pigments called as bilirubin and biliverdin. Bilirubin and biliverdin, which are eliminated through the alimentary canal by bile. By bile, through bile, these bilirubin and biliverdin, they are eliminated through our alimentary canal, because bile from the liver is drained into the alimentary canal. So the bile pigments, bilirubin and biliverdin, which are formed from the degraded hemoglobin, will be eliminated from the body through our alimentary canal. Okay. And even some other substances like cholesterol, drugs, vitamins, steroid hormones, all these are degraded and eliminated by the lungs only. Cholesterol, drugs, vitamins and steroid hormones, all of them are degraded in the liver only, and they are eliminated by the liver. In that way, liver is going to participate in excretion. It is going to degrade the hemoglobin of the dead red blood cells to give bilirubin and biliverdin, which are bile pigments. They are sent out of the body through the bile into our alimentary canal. The bile is released through our alimentary canal. They are sent out of our body. And we have the degraded cholesterol, drugs, vitamins, steroid hormones. All of them, they are going to be degraded with the lungs only, and they are eliminated out of our body. Okay. Then the last organ we are going to study, which is going to help in excretion, is skin. Skin is also going to participate in excretion because skin is going to contain two types of glands. The first type of gland is sweat glands. The main effect of the sweat glands is to give a cooling effect to our body whenever we are feeling very hot, isn't it? Whenever we are feeling very hot, then immediately we start to sweat. The isn't it? Whenever we are very hot, whenever we are feeling very hot, we start to sweat. So that sweating is just but to give a cooling effect to our body. So other than giving a cooling effect to the body, the sweat glands they also excrete some amount of sodium chloride, urea and lactic acid. They are going to eliminate sodium chloride, urea and lactic acid. Okay. And then we have the other type of glands in the skin called sebaceous glands. They are going to eliminate steroids, hydrocarbons and waxes from our body in the form of sebum. In the form of sebum. In the form of sebum. Sebaceous glands are also present in the skin. They are going to eliminate steroids, hydrocarbons and waxes from our body in the form of sebum. The form of sebum. This sebum is nothing but that oily, sticky substance which is produced on our skin. Generally, all the skin, any person's skin is going to produce some amount of oil, isn't it? So that oily, sticky substance which is produced by the sebaceous gland is called as sebum, through which steroids, hydrocarbons, and waxes are also eliminated from our body. Okay, so in this way, there are these three different organs: lungs, liver, and skin. These three different organs they are going to perform excretion other than kidneys. Along with kidneys, these three parts are also going to be involved in excretion. So now we are going to learn regarding the last concept in excretory process and their elimination, that is the disorders of the excretory system. This is going to be our last topic, disorders of the excretory system. Okay, so we are going to learn regarding few disorders related to excretory system. Let us see what they are. First one is uremia. Uremia. So uremia is a condition in which there is increased amounts of urea in the blood. Uremia is a condition in which there is increased amounts of urea in the blood. There is going to be increased amounts of urea in the blood. So this increased amount of urea in the blood, it can be due to glomerulonephritis. Which is nothing but glomerulonephritis is nothing but inflammation of the glomerulus. Inflammation of the glomerulus. Or it could be due to hypertension. Or it may be due to diabetes. Uremia is nothing but increased amounts of urea in the blood which is caused due to glomerulonephritis or hypertension or diabetes. These are the reasons behind uremia. Then we have renal calculi. Renal calculi is nothing but kidney stones. Renal calculi is nothing but kidney stones. You might have all the families with this term called kidney stones. So there are actually no stones formed in the kidneys. This is actually the situation during which there are hard crystallizable substances. Which are found in the urinary tract, either in the ureters or in the urinary bladder. There are some hard crystallizable substances which are present in the ureters or in the urinary bladder. Okay. So sometimes there are some hard crystallizable substances present in the urinary bladder or the ureters. So these hard crystallizable substances are going to form whenever there is increased amounts of uric acid or oxalates. Whenever uric acid or oxalate amounts are going to increase in the body, then they are going to settle down in the excretory system in the form of hard crystallizable substances. They are not actually any stones found in the kidneys. They are nothing but the crystals of uric acid or oxalates which are found in the the renal calculi is dehydration. Dehydration. The major reason for formation of the renal calculi or the major risk during the occurrence of renal calculi is the dehydration only. That means reduced amounts of water in the body is going to be the main reason and also major risk factor during renal calculi. Okay, so this is what we have renal calculi. Regarding renal calculi, which means nothing but kidney stones, during which there are hard crystallizable substances found in the ureter or the urinary bladder. These hard crystallizable substances are nothing but those crystallizable substances. When they are formed, when there is an increased amount of uric acid or oxalates in the body, then they are going to get crystallized and settle down in the ureters or the urinary bladder. So, the major risk factor or the major causative of renal calculi is dehydration. Then we will learn in detail regarding glomerulonephritis. What is glomerulonephritis? Glomerulonephritis is nothing but the inflammation of the glomerulus or the small blood vessels in the kidney. Okay, the inflammation of the glomerulus or the small blood vessels in the kidney is going to cause glomerulonephritis. It could be caused due to infection. It is going to occur due to infection. The infection can be anything. It could be caused due to infection. The infection can be due to anything. It could be a bacterial, viral, or any parasitic infections. They are going to cause glomerulonephritis. Then hematuria. Hematuria is a condition where there is blood in the urine. Hematuria is a condition where there is blood in urine. Blood in urine is called hematuria. Then we have pyelonephritis. Pyelonephritis is nothing but the inflammation of the renal calyces, renal pelvis and the interstitial tissue. Pyelonephritis is nothing but the inflammation of renal calyces, renal pelvis and the interstitial tissue. It's called as pyelonephritis. The inflammation of the renal calyces or the renal pelvis or the interstitial tissue is called as pyelonephritis. Okay. Then we have the last disorder related to the excretory system, that is renal failure. Renal failure is nothing but the failure of the kidneys to perform the filtration of the blood. That means the kidneys are going to fail to function properly. That is called renal failure. Okay, renal failure is nothing but the failing of the kidneys to function properly. It's called renal failure. So, in the persons who are suffering from uremia, where there is urea in the blood, that means here also the kidneys are not working properly. And also in the renal failure, for these two people who are suffering from uremia as well as kidney failure, there is a very big boon that is there to these people. That is hemodialysis. There is a process which is called as hemodialysis, during which the blood of the person is filtered by the machine itself. There is a machine used in hemodialysis which is going to do the job of the kidney. Let us learn in detail regarding what is hemodialysis. Hemodialysis is nothing but, see, in the persons who are suffering from renal failure or the persons who are suffering from uremia, and then the kidneys are not working properly. So what is that? So the blood is drawn out of the body of the affected individual, the patient. The blood is drawn out of the body of the patient, filtered outside the body of the patient and again sent back into the body. That is hemodialysis. To simplify it, we can say that the affected person who is having renal failure or uremia, because the kidneys are not working properly, the blood is drawn out of the body, filtered out of the body and again sent into the body. That is actually what is happening during hemodialysis. Let us learn in detail. So during hemodialysis, let me draw a picture first. This is going to be a rough figure which is going to explain us regarding how hemodialysis is going to actually happen. So this is the dialyzer. So this is how, this is just a rough figure for our understanding point of view how this dialysis is performed. Okay. So first, from the main artery of the affected individual, the blood is drawn out. So here, from the main artery of the affected individual, the blood is going to be drawn out. So whenever the blood is drawn out of the body, there is a chance for the blood to be getting clotted. Is it clear? So here, when the blood is drawn out of the body from the arteries, the blood is going to be drawn out. Generally to the radial artery, the blood is going to be drawn out into it. Heparin, which is an anticoagulant, is added. And it is going to be drained into the dialyzer. In the dialyzer, there are different channels which are made of cellophane. In the dialyzer, there are different channels which are made of cellophane. In the dialyzing machine. So this is a dialyzer. Here it is going to have some channels which are made of cellophane. So in this dialyzer machine, both blood and the dialyzing fluid, both of them are going to flow. Both blood and dialyzing fluid, both of them are going to flow. Blood and dialyzing fluid, both of them are going to flow in the dialyzer. But these two, they have same composition. The blood and the dialyzing fluid, both of them, they are going to have the same composition, except one difference. In the blood, there are some waste materials, whereas in the dialyzing fluid, there are no waste materials. That is the only difference between the blood and the dialyzing fluid. In the blood, there are waste materials which have to be removed. In the dialyzing fluid, there are no waste materials. So, in the dialyzer, both blood and dialyzing fluid are going to flow in the channels which are made up of cellophane. So, this cellophane is going to allow the movement of the substances according to their concentration gradients. Cellophane is going to allow the movement of the substances across. So, because the dialyzing fluid and blood, both of them are in same composition, through the cellophane channels, only the waste materials are going to enter from blood into the dialyzing fluid. Because anyhow, the waste materials are going to move from a higher solute concentrations to lower solute concentrations. This is very basic that we all know. So, any substance is going to move from a higher solute concentration to a lower solute concentration. In the same way, the waste materials, because they are present in the blood and not present in the dialyzing fluid, the waste materials are going to be flowing into the dialyzing fluid from the blood. So, continuously, fresh dialyzing fluid will be flowing in the dialyzing machine, dialyzer, and the loose dialyzing fluid is going to be drained out into a separate chamber. Loose one is drained into a separate chamber, and continuously fresh dialyzing fluid is going to flow in the dialyzer. and when these two, the blood and the dialytic fluid, both of them they are flowing in the dialyzing machine, because the dialytic fluid and the blood, both of them are having the same composition, except there are no waste materials in the dialytic fluid. So the cellophane channel in the dialysis is going to allow the movement of the waste materials into the dialyzing fluid, and that used dialyzing fluid is going to be kept separately. And after that, whatever the clean blood is there, pure blood is there, that is again sent back into the body through radial vein. Radial vein. Generally through any large vein, but mostly through the radial vein it is going to be sent into the body. Here when taking the blood out of the body, we have added heparin. So when sending the blood back into the body, we are going to add anti-heparin. We are going to add anti-heparin and send it into the body. In that way, this dialysis is performed. It is going to last for about 2 to 4 hours, and this is a very big boon for those individuals suffering from renal failure and uremia, just to increase the lifespan of the individual. Okay, this is all that we have regarding hemodialysis. And the other option for those persons suffering from uremia and kidney failure is transplantation. Kidney transplantation is also performed. We can transplant the kidney. A healthy kidney from a donor can be used to transplant it in the place of an infected kidney also. That is also performed. And nowadays there are increased successes of the kidney transplantation are also being seen these days. So that is also another good option for the persons who are suffering from uremia as well as kidney failures. So this is all that we have learned regarding today's class, expiratory products and elimination. With this we have finished with this chapter, expiratory products and elimination, and tomorrow I will meet you all again with a new chapter. Thank you all for joining.